it's my great pleasure to be hosting our next panel, which is going to be shifting focus a little bit. We've talked in the last panel about predicting where AI is going as a field in the future, and in this panel we're going to focus a little bit more on predicting what a particular system might do, how it might behave, and how well. We have on our panel Lucy Cheke and Joel Leibo, who you've already heard from today, and they're also joined by Peter Flach from the University of Bristol and Ali Boyle from the London School of Economics. To start us off, I think it's really important to get on the same page about what we're really talking about when we talk about predictability in terms of a specific system. So my first question is, what are the things we actually want to be able to predict in terms of a specific system, and why is it important to be able to predict those things? Maybe we'll start with Ali.
Sure. So I think there's lots of different things we might mean when we talk about the predictability of a particular system, and some of those are going to matter more for some projects than others. So you might just be interested in predicting how well a system is going to perform at a particular task, like how successful it will be. That might be very important for engineering purposes. You might be interested in the sorts of stuff that Lucy was talking about, like particular patterns of behaviour. And that's the kind of thing that's going to be really important for things like cognitive evaluation, also for things like, safety, like what are the specific failure modes of a system, under what conditions will it work, under what conditions will it not work. Then I guess there's the more kind of theoretical stuff that Lucy was talking about, like what would we expect this system to do if it had a cognitive capacity that we're interested in. And that kind of question might be sensitive to other predictions that you would make about a system, like in animals, for instance, you think you have to ask those questions, given that this creature is a predator, like how would we expect this capacity to manifest? Because cognitive capacities you're not going to make the same predictions about every different type of agent on the assumption that it has a cognitive capacity. So I think, there's lots of things we might mean, and it kind of depends on what research project we're engaged in.
Yeah, that makes a lot of sense. Thoughts from others?
Yeah, I guess I'll jump in there. I guess what's really interesting to me is you start from the questions that are a bit like what the things Lucy was just talking about, right? Where you kind of probing an individual. But what I want to know is more like what happens if you put a bunch of them together and embed them in a world with humans that all have different incentives and different learn in different ways, and what would come out from that, right? And what's predictable about this is in some ways it's like the forecasting question of like we're predicting the future about things, but also the kinds of stuff that I was talking about were basically agent-based simulation methods. So you can try to run things in simulation, search for principles that would then find kind of causal forces in how multi-agent systems evolve. And I think that's really the kind of computational social science sort of angle on what you could get out of this, where you might be able to predict new things about the future or whatever.
Yeah, I think also it's important to think about the level of granularity that you talk about. So very simple example and trivial in some sense, but if you think about tossing a coin, then if it's a fair coin, then it's fundamentally unpredictable what the next coin toss is going to be. On the other hand, we know everything that there is to know about the coin. And moreover, we know that if we do it often enough, it asymptotes to 0.5. So is it predictable at the individual coin toss level? No. Is it predictable as a system? Yes. So I think that's relevant. And that may come up, but just to make another comment is predictability also involves some way of measuring what the system is going to do. And measuring is very hard. And I've heard this, the many fascinating talks today, and I've heard a couple of times, oh, if only we had a metric to do something. We shouldn't forget about the Goodhart problem, because we're optimizers. We are particularly, we will fall victim to the Goodhart paradox as soon as a metric is, you take it as an objective, then it feels to be a good metric. And so I would say that we need to actually delay as much as possible having a metric until we actually understand what it is that we're measuring. Or even in the case of the Turing test, kind of avoid having a metric at all, in the idea of, well, I don't know what intelligence is, but I recognize it if I see it, and then you do some kind of experiment with users. But unfortunately, or fortunately maybe, the Turing test is dead now that we have ChatGPT. So maybe that's a good thing. Yeah, so the points I'm making is particularly before we measure we shouldn't rush into measuring things if they are things that we don't fully understand.
Yeah, if I can just add a tiny addendum to that, I think the fact that we are optimizers should be a motivation for us to so at the moment, a lot of benchmarking is what is the best? Like, which is the best reinforcement learning model? Which is the best foundation model? And actually, if we're optimizing, we should say, which one is good enough for the purposes that I need it for? Based on how expensive, how, in money, but also in compute and in energy. And if you can predict the behavior of an agent, it fails here and here and here and here, but I'm not using it for any of those things. I don't need it to pass those. I don't need it to be the best. I need it to be good here. And if I can predict it well enough and precisely enough, then I can say, well, this is good enough. And I think we struggle at the moment with that because we don't have a good definition of good enough because we don't have the predictability to know where it will be good and where it will be bad.
Yeah,
Wait,
I think.
you go
Sorry,
ahead.
I think also there's competing interests when it comes to what is good enough. So, just anecdotally, in my department, and I imagine in all departments, there's a lot of concern about ChatGPT being used to write essays. So we're all trying to figure out what are the predictable mistakes that ChatGPT will make. But I'm sure if we ever successfully identify the mistakes that ChatGPT makes, it will then become a target for them to stop making those mistakes.
Yeah, and what is a good enough essay? If it can write an essay that's that'll get you a third, it's wow, didn't need to pass. So yeah.
The difficult thing about even for some system that exists right now, you're making predictions. It's how will people use it, right? Different people have different incentives and will want to use things in all kinds of ways that are hard to anticipate. So it's not just does the system have this capability or whatever. It's more people will come up with ways of using it that are combining with other things that are just very very difficult. And what you need though is some kind of more. We need to think about the whole ecosystem around it, what kinds of norms and institutions we have as users and as people creating these things and people who are talking to policymakers and stuff. What does the whole system end up looking like? And it has to be robust to the fact that people will have very different incentives and there are plenty of malicious incentives there.
Do you think that the fact that we're now building more and more general systems being used by more people is making those challenges is harder?
I think we're just integrating into the world more, right? There's more levers for things to happen, right? If you just have something, if you have a language model that's really just remains completely a language model that never gets any affordances in the world, you never can take any actions, then that's a very different looking system versus one that suddenly has some actions and can do something.
Yeah. I want to come back to something that Peter said about a coin toss, which is just fundamentally unpredictable. And I've been thinking a lot as we've been talking about the comparison between humans and AI systems, that in many ways humans are quite unpredictable. Mm-hmm. And so should we expect our AI systems to be predictable if they're going to be engaging in these kinds of complex behaviors?
Yeah, I suppose for some purposes you should neither expect nor want it, right? So one of the great hopes for AI is that it will help us solve problems that we can't solve already. So if we had a fully predictable system for those purposes, that would be unsuccessful.
There's prediction and there's individual prediction, right?
Yeah.
You could make an aggregate prediction about how most people will behave a certain way in this kind of situation, and those things we can in some situations we know a lot.
For sure.
But often what will any one individual do with the diagnostic kind of level stuff is we don't usually have that.
Well, yeah, I think when it comes to humans, it also depends who's doing the predicting. I can predict what my husband will do really well because I know him really well. So the better we know the AIs, the more we can predict them, and the better we know humans, the more we can predict them. It's not that people are fundamentally unpredictable. Obviously there are margins of error, but it's that the people trying to predict humans are trying to predict humans from 10 miles away based on such rough-grained analytics that there's like, well, you're a woman at about like this age, so I guess you probably want makeup adverts. Like, on a population level, that's kind of fine, it works, but at an individual level, that's going to be way off. So I think, you know, what we see in some of the like Cambridge Analytica stuff is that you get a good enough knowledge of people and you can predict them well enough to really make a difference to what they do. And I think turning that on its head, if we could do that back at the AIs, that would be an advantage. So yeah, I think it's the same thing. The more you know something, the more you understand something, the better you know it, the more you can predict it. And that's true no matter what system you're dealing with.
Maybe to put something else in the mix. So there's actually quite old AI approaches to things like diagnosis, so either medical diagnosis or diagnosis of engineered systems. And so typically what you have then is a model of normal behavior, and you have a fault model. In fact, you know, you could argue that medical practitioners need to know more about how human bodies go wrong than that they need to know about how they normally work, because if the body works as it should, then probably they don't go to their GP. So so there is a, you know, I'm thinking, is my car predictable? Well, in some sense it is, but it requires input from me. But at some point it starts making funny noises, or some things stop working, and then there is something wrong. And I think related to that, you have this notion of operating conditions. So let's say my phone or my tablet is probably, you know, there's probably a fact sheet somewhere that says, you know, don't operate outside -10 to 40 degrees. And in fact, my phone probably has a temperature sensor and actually, you know, switches off or does something, you know, disconnects the battery or whatever when it gets too hot and so on. So I think there is also moving away slightly from predictability and sort of saying, well, there is this kind of safe set of conditions where you expect the system to behave normally and doing what it does. And then maybe there is another set of conditions that if you step outside of there, then sort of anything may happen.
So can I just quickly follow up on that? Like, so in that case, I mean, obviously not in an AI way, but your phone is knowing its own limitations and then acting to stop itself causing problems. So is it that we need to predict the AIs, or is it that the AIs need to predict themselves?
I think the latter is, I think a big problem that we have with trustworthiness of AI and so on is because we build algorithms that always give an answer. You know, like k-means or dendrograms or so. They just, and it doesn't necessarily scream out at you that the answer doesn't make sense. I mean, I needed to actually run the hierarchical clustering algorithm on some uniformly distributed data to see what kind of dendrogram I got out of it, and it looked perfectly respectable. And if you do it in MATLAB, you get clusters of 3 colors, and it is just a random partitioning of your space. So. And I think the same problem we have with ChatGPT, which sometimes has been described as mansplaining as a service. And the important thing there, it does it with complete confidence. It doesn't, you know, and actually, if it's a word sequence prediction thing, it may have had n number of words with some kind of near uniform distribution of probabilities. And if you do an argmax, you just pick one of those. And it doesn't tell you whether it was one of those situations or whether it was a 0.99 and then all the other alternatives were very small probabilities. So I definitely think a lot of problems in AI, I think, would go away or would be much less prominent if we build algorithms that actually say, I don't know, more often.
Yeah, it would be great to get some questions from the audience. So, yep. If we could get Kazi first, and then I'll come to you, Pablo.
Hi. I'm wondering whether to what extent the answer to the question, how predictable can AI systems be, is dependent on the answer to the question of how explainable can AI systems be? Can we make good predictions without good explanations? Can we make good explanations without good predictions? Vice versa.
Yeah.
It's another tricky term, right? Which we in AI bandy around as if we all know what it is, and we even build explainable AI systems. And it's for me, I think explainability is linked to understanding. So sometimes one word is enough, and then suddenly something clicks, and I understand it. So, yeah, understanding. I mean, do I understand my robot vacuum cleaner? Well, again, I mean, going back to a random system, I don't understand that when it bangs into something, it goes left rather than right, but there's nothing to understand about that. I do understand it, that if I leave it on its own and I come back after a while, it should be back at its charging station because the battery has gone. So it doesn't explain that to me, but I have that understanding, and maybe it doesn't need explaining, but other things do need explaining.
So part of the reason to care about explainability, I think a pretty big part of it is really to assign responsibility. Like we as people have intuitions about like the causes for my decision should be, like if I say this is why I did it, then, and if that's a good reason, then it's defensible. If it's a bad reason and I did it anyway, then it's like I'm responsible for some bad thing, and that's, the intentions you have when you do something matter, right? So it's not just the consequences, right? And that's how we kind of intuit things. And so we kind of want to treat our AI systems the same way. Like we want to know, like, well, this is what caused it to make this decision and have these consequences, and then assign responsibility accordingly. But it's not always, we don't need to think of responsibility that way, right? Like there was a talk this morning about different ways of assigning liability, and they weren't all necessarily like that. Some of them had us thinking about the consequences, and it's you could imagine. The creators would be assigned blame for something going wrong if the consequences are bad, and they could have foreseen that or something like that. And maybe that matters, that it was like this is how the system got to that answer, but maybe that doesn't matter at all. It's just it's outside the system that's important. So insofar as explainability is about assigning responsibility, then sometimes we care about having real verbalizable, low-dimensional explanations, but sometimes maybe they just could be more complex explanations, which are sufficient for responsibility. And
I think, it's a bit like the coin toss thing to me. It's about the level of granularity, because sometimes you can say, I know that when you have X, this happens, when you have Y, this happens, and when you have X and Y together, this other thing happens. Do I know why X and Y interact that way? No, but I know that they do. So you can have, a reliability based on what you understand at a level of granularity, and I think that's the thing that's important. Like having a good relationship between the degree to which it is explainable and whether or not that relates to the reliability given that understanding. And so you don't have to have full understanding. You just have to have enough understanding for the reliability and the predictability to work. It's the same thing. I don't quite really understand how it is that when I press X on my keyboard, an X appears on my screen. I am not an electronic engineer, but it does, and it does every time. And the person who made it knows why, and that's enough.
Ali, do you have thoughts?
Yeah, I suppose just coming from like a philosophy of science background as well, one thing to say is like there are different norms that govern the success of explanations and predictions. So if you're thinking about explanation in terms of like describing the causal process by which something occurred, and you have like a kind of empirical adequacy as like the only constraint on what makes it a good explanation, then there's going to be a really close connection between explanation and prediction, I think. But in general, we evaluate explanations as being good or bad, not solely on like empirical adequacy grounds, but also on like non-epistemic norms like simplicity, elegance, fit. And on that way of looking at it, having a good explanation, however important it might be, is maybe like a more difficult thing than like having predictability.
I think we had a question from over here, maybe.
So I guess similar question to the other panel. To what degree are we going to, or to what degree can we figure out methods to evaluate systems that are highly capable? Especially, I mean, the issue is that animals are much more like us in the sense that they're very similar. They want food, they want similar things, and they have very similar pattern recognition. But AIs are very different, and their methods of being trained are also very different. So how are we going to evaluate them when they become very capable, and especially make sure they are safe, or they are optimizing for the correct things?
So big question, there's a lot to unpack there. I mean, I think some of the stuff you talked about, Lucy, is very relevant to this.
I mean, there is an extent to which biological brains are biological brains, but many of them have their common ancestor like way back in the tree. So there has been convergent and divergent evolution of intelligence, which means that we have in our data set of minds, if you like, some really different ones that behave in very different ways. And so, you know, what you see in an octopus intelligence is using a different hardware, like very different hardware. It's still biological, but it's very different to a human. Meanwhile, you can have something like a bee where the hardware in the individual animal is extremely simple, like simple enough that we know what all the neurons are and where they are and how they connect. But actually that's not where the intelligence lies so much. The intelligence lies in the fact that there's 300 of them coordinating together. It's the hive mind. And that's really different again. So what the benefit of having that approach is, I think, that we can say, well, we're trying to make sure that we have ways of understanding that cover that kind of mind and that kind of mind and that kind of mind. And yeah, AI is going to be a really different kind of mind again. And you know, we have the same question. We talk about, like, what if there was an alien? If an alien intelligence came, how would we know that it was intelligent? What would it look like? How would we know what it would look like? We don't, but we know we can develop tools to say that are as hardware agnostic as we can possibly get once we've experienced all of these different ways that it can be applied. And I think the humans being really, really clever helps us kind of, you know, differentiate between humans is hard because they are very clever and very general. I think one of the challenges that I think may slightly underpin your question is some of the very, very general intelligences we have within AI. It's not so much that they are general, it's that they've been trained on everything that exists. Like the language model has been trained on the whole internet. So it's a double problem because the intelligence is general, but it contains everything we've ever written down about how to understand intelligence. So that's all contained within the problem. So that is a special problem that's above and beyond just the fact that it is a very capable, very general intelligence. And I think that's one of the really major challenges.
So when I think about, like, very capable agents and superintelligence kind of things, I think a useful intuition bump is thinking about corporations, which are superintelligences, which exist, you know, and we have lots to say about them. We understand some things. We worry about their being misaligned. We think about their governance. And they're certainly more intelligent than any individual human, right? So there's a lot of things in common here. And we have some kind of, like, established frameworks for thinking about governance, right? It's like we know, you know, that there are you can have regulators and you can have competition between corporations, and you want to set up things in certain ways, and it's all kind of things that we can kind of understand. But it's a large multi-agent system with governments involved and policymakers, and it's not necessarily the case that any one individual even understands all of how corporations are regulated. That's also a multi-agent thing. So on the you were talking about bees a second ago. Like I actually think humans are potentially much more like bees, and most of our the things that we're really proud of as our intelligence as a species is really more group collective phenomena. But that remains true as we create more intelligences at different scales and sizes and augment our ecosystem with more things. And
We add AIs to the hive.
I want to stay with this thread on evaluation because I think it's a really important one. One of the things that we've been really conscious of is that as these systems become more general, the cost of evaluating them is also becoming much larger because the systems are more expensive to run and there are more things that you need to evaluate. So is that extra cost of evaluation something we should just accept, or do we need to start rethinking the way we evaluate systems to try and make it more efficient?
I think, well, it depends a bit on what you mean by evaluation here, but I think in this sort of academic rat race, our evaluation tends to become more primitive just by every version of NeurIPS. And I think that...
What do you mean by more primitive?
I mean that, the typical NeurIPS paper with the big table in the back with the bold numbers in the right places, and as if that, demonstrates anything. That this is endemic, I think, in academia and isn't doing us a service because it's sort of suggesting progress where progress doesn't actually exist.
So you think that basically we're not robustly evaluating these systems? Is that what you're saying?
No, because it's become very formulaic, I think, and so it's so a little bit of history. And I've been long enough in AI, and I've said this before, that that I remember AI being a decidedly non-fashionable topic. And machine learning actually initially was much more adventurous than it is now, but it had an evaluation problem. So Patrick Winston's arch, learning an arch from images and so on. That was basically, we would now say, oh, that's only toy problems. There's no stats in there. Sort of, it was a bit like look, ma, no hands. And then Pat Langley sort of started complaining about that and said, oh, we need to do more robust evaluation. And then actually what happened was we changed the problem in things that were more easily evaluated, and sort of hence the enormous focus on classification, and that became the prototypical machine learning task. So we kind of narrowed the field, or sort of we, when I say we, I'm involved in that as well, but there was a narrowing of the field. There was also a move towards the lamppost where my keys probably aren't, but at least there's light there, so I can do some systematic evaluation there. So I think we shouldn't forget that these things tend to happen when we sort of we have it's such a big academia is such a big environment now, and everybody's trying to do the same thing and sort of being successful in there, and that there are disadvantages there.
Yeah, I mean, I guess one of the interesting things about AI relative to other fields is there's so much research also happening in industry. So, Joel, from your perspective, what do you see in terms of evaluation practices at places like DeepMind, and do you think they're robust enough? Do you think that they're efficient?
Yeah, well, we do a lot of different things, right? So some evaluation is like you have some system and you want to know, does it really, do what you want it to do, or maybe it can do new things you didn't realize or something. That's one kind of thing that happens. But there's also a lot of stuff that's more like test-driven development, right? Where you make an evaluation first and nothing can solve it yet, but you have that and then you have a concrete number and it's bad and you work on pushing it up. And lots of projects are oriented that way, right? Like Melting Pot, our kind of suite of environments and contests we're putting together is like that. Right? It's an unsolved problem, but that gives you a number to measure, and then you can try to develop algorithms that do solve it. So I don't know. I guess I see there's all kinds of different things that are happening. I totally see your point about lots of NeurIPS papers just have a table in the back with something in bold, and maybe sometimes they do a t-test between those, but usually they don't even do that. And there's definitely more, generally more kind of like quantitative, empirical, just how do you do simple hypothesis testing kind of knowledge in other fields that's usually not present in most machine learning education. I kind of think it's more of like it's an all of the above. Like we need kind of more of all of these things, and probably just in general to invest much more in evaluation. I mean, because now these things are getting real, and we should just be kind of putting more into it.
Right. Other questions from the audience? Yeah, Jose?
I'm not sure if it's working. You probably need to.
Can we grab the other mic for Jose, or someone help him out?
You can use this.
It's a very short question. Do you think that AI will be more predictable or less predictable in the future? And of course, we have a say here, we have an action to take, but what's your take on this?
So, I mean, AI in the world, you put it in the world, you put more affordances in, then it becomes multiplied by all of the people and all of their intentions. And I don't want to sound defeatist about it. I don't think I'm not defeatist about it. I think we just need to see it as kind of a social science question, right? It's like the whole system is really, it needs to be thought about in order to predict anything. And I think that is tractable because there are principles there. But it's definitely it's definitely increasing in scope as we deploy these things.
I wonder if it's a non-linear answer, that as AI becomes less predictable, suddenly people are going to start to realize that they need to evaluate it properly. Then they're going to put the more money into the evaluation, then maybe the AI will become more predictable as a result of that. I think one of the, there was this question about kind of narratives and stuff before, that I think one of the problems we've had so far is that people intuitively feel like they can predict the AI. They're like, yeah, it can do this, it can do that. And so you get this situation where the assessment is a bit of testing and a lot of intuition. And I think once they get to a level of complexity and unpredictability where it becomes clear that you can't do that, then you may start to find that actually you start paying attention to the best ways of evaluating, the best ways of assessing, and then you may come back the other way. So yes and no.
Ali, any thoughts?
Yeah, I mean, I suppose it's a two-part question as well, isn't it? It's like, how is AI going to change and how are we going to change? We might put pressure on the development of AI systems to make it more predictable, but there'll also be pressure on us to understand better how they work. So I suppose that makes me think the trend is going to be towards predictability when you consider the interaction of those two things, but I might be optimistic.
There's just one argument that people sometimes say that you maybe if you see like the social media as like making the people more predictable in order to sell them things or something like that, maybe will have some effect on us as well by the other actors in this ecosystem.
Yeah, there's definitely interaction effects there. I mean, let's face it. So we had to learn how to use Google effectively. So Google appeared, and then initially we start to type fully grammatically correct questions, and then we realized that we can drop most words, and actually some words like negation are not handled correctly at all. So don't ask Google questions with a negation in there. So we are adapting to the technology, and the same thing is happening with ChatGPT as well. Now there's prompt engineering. We need to figure out how to again ask the right question to get the answer we expect or we want. But what I think it's again with ChatGPT is really interesting for me is that fundamentally it's this basic capability. It's a language model. It can predict the next word, and suddenly all these other capabilities appear. They're maybe not all good and correct and so on, but I find it absolutely fascinating how people find all sorts of new things to do with ChatGPT, like writing computer code or debugging code or explaining code or whatever it is. But it is just a language model. So then we also have the effect that suddenly people say, oh, it hallucinates, as if that's a bad thing. But that's the whole point of a language model. It's kind of making, building sentences that maybe nobody ever spoke before, but have some kind of coherence. So
if you have a system that is capable of doing so many things like this, how do you decide what are the right things to evaluate? Like if you take ChatGPT, what are the things we need to evaluate it for, and how do we figure those things out.
I wonder, on the question of, do things become more predictable, like, if you imagine a sort of equilibrium picture in the end where, there's so many undesirable behaviors, right? You can ask ChatGPT to write your misinformation for you and spam that, we'll have to move to some kind of world where there are also AI systems that are policing the uses of AI systems, because there'll be new prompt hackings and new malicious uses at it all the time, because there are malicious humans, right? You can't, you have to assume that. And so you need some kind of AI policing or something like that, maybe run by regulators or maybe run by other, just something within the system itself. Could be lots of ways of doing it. But then you could imagine that there's an equilibrium inside of the system, and maybe then things do start to become more predictable, where it's okay, probably prompt hacking isn't going to work, because if it were to work, then this other system would have stopped it, and you can get some kind of measure of expectation of what things are likely to happen.
It seems like cognitive theories probably come into this as well, right? In terms of understanding what are the different kinds of things that these systems might be able to do, and what do we might want them to do.
I mean, I think there's two, I mean, it's probably lots, but there's two in the top of my head. One is obviously, being able to predict what it's going to do based on its capabilities, which we've talked a lot about. But the other one is, if we know what humans do and how they do it versus what the system does and how it does it, then that can be used as a way of saying, actually, a human didn't write that. So part of the predictability is the distinguishability and and that is what allows the policing, because you can't get rid of chatbots if chatbots are indiscriminable from humans writing the same thing. Well, you can ban humans and ChatGPT from doing the same thing because the thing itself is bad. But you could have others where it's fine if a human does it, but if some AI farm is making thousands and thousands of AIs to do it, that's not fine. And then you need to be able to tell the difference. And being able to know the capabilities of the system means that you can say, right, this pattern of passes and failures is characteristic of a language model. Of course, what you have to do then is never publish that. Don't put it on the internet, otherwise ChatGPT will know, and then it'll all be wrong. But in theory, it's the fingerprint. You need to be able to know the fingerprint so that you can tell the difference, because there are things that are inherently bad and the things that are bad if it's an AI doing it. And we need to be able to tell.
It would be really useful if we could watermark ChatGPT output in the same way as we can watermark images. Yeah,
So they are doing that, right? It's just a watermark. They're starting to do that, but it requires a chunk of text to work. So if it's a very short response, you're not going to be able to see it. But the problem with that is you have to, again, if thinking about a whole ecosystem, right? Anyone who wants that to not work can just train another language model to remove the watermark. You can flood the internet with text created by that, or whatever you want, and it's not. You need to have some system that is kind of robust to the fact that some people want to break the other safeguards.
Yeah.
I mean, it doesn't help, in things like capture, that the thing we use to tell that it's a human is the thing they train it on. As an approach, I feel I see a flaw. We need to have capture, basically, for the new kinds of models that we have, and I think that the only way to do that is cognitively.
I guess you're really touching on a pretty philosophical question there about should we be aiming for human-like AI? And if we have systems that can behave in the same way as humans or do the things that humans do, is that problematic? Is that something we should be aiming for? Things like that.
I think one of the principles that's emerging from some of I'm definitely not involved in any kind of policy discussions, but I think a lot of people are talking about just saying that the rule and norm should be that AI systems have to identify themselves as AI systems. And if you're saying that, okay, you have to say that, then it's maybe you can act you can let it act in a human-like way afterwards, as long as it's always identifying itself. But then you really want to create lots of penalties for violating that in a product, or at least, or in something. It becomes you have to think about the whole system around when do those things get triggered, and do you ever catch people, and
Yeah.
I think human likeness is the aim in some circumstances, and doing the job best is the aim in other circumstances. And when you come to nefarious uses, then that becomes extremely complicated. But if we want medicine to improve, then human-like AI would be really good. not for like analysing the data or being the doctor necessarily, but for being the human, being a model of the human. So, well, what happens if we break that? Because you can't go, ethically, there are some problems with doing that with people. So, there are lots of reasons to want human-like AI, but that might be not because the way humans do it is the best way. It's because we want to understand humans better.
Yeah.
If we want to say what's the best way of doing that, then I think the answer is almost always going to be not human-like in some particular way, because we make compromises when we're good at everything. We're kind of pretty good at everything, but we're not the best at anything. And sometimes you want something to be the best at something.
Yeah, and sometimes you want something not to be subject to the characteristic pattern of errors that we're subject to, or to the characteristic biases that we're subject to. I mean, this is clearly in the background of some, turned out to be very problematic applications of AI. It's like, oh, let's use AI for sentencing. That won't introduce biases.
Right.
Which, I mean, the feedback thing there is, what is the AI trained on? The AI is trained on the biased and problematic data that we have produced. So it might be the best at using the data we've produced to make a prediction, but not the best at predicting what's the ultimate and most desirable outcome is.
But
Those are different
at
questions.
least it won't take different decisions before and after lunch, right?
I don't think that study replicates.
It doesn't replicate. Yeah, it doesn't replicate.
Decisions before and after fine-tuning. Via lunch.
Thank you. Other questions from the audience? Yeah, Alexin.
I've learned compute today. I cannot answer the question.
Can you hear me? Okay, great.
Yeah.
So my question is very straightforward. Because I see a very lacking open source amount of evaluation results being published, and namely, should we rethink the way that we publish our results when we do some research? It's not only about the code for order to being able to reproduce our result, but also the empirical evaluation result that we obtained, and make that open source so that other people who are more interested in evaluation can have more easier access to these things, so that this can be more evaluated in a more transparent way. Because otherwise, if we don't have this evaluation result, it feels like, okay, I have these big models, it's published there, we don't have the code, we don't have the evaluation result, neither, we cannot evaluate, so it's much even harder to understand the behavior delimitation and being able to predict what they can do when being deployed to the real world. So, what do you think? Whether should we reframe this convention of publishing results, and why people are not so incentive to publish these results, and what seems to be the most effective way or remedy that we could take to motivate academia and even companies, researchers, to publish these results in a more consistent way?
Who evaluates the evaluators?
Mm-hmm. So one thing that a lot of fields have norms of you should put out your work in a way that facilitates meta-analysis, because with the assumption that there's going to be other people afterwards who are going to be not looking at primary data, but doing these kind of reviews that look at lots of papers and then do secondary analyses on top. And often that's, in many fields, that's the norm, that you expect people to do that, and reviewers will say oh, why are you, we'll sort of enforce it. But we don't really have that culture in AI, and we probably should. There's probably a lot of low-hanging fruit there.
Why do you think that is? Why do you think we don't have this culture of sharing?
Well, I think for a long time there have been things have been so different from each other, right? I have some evaluation that I care about, other people don't care about. The conditions are just so different that that kind of set the culture along a certain path that maybe should be rethought now.
Yeah. There's kind of a larger issue at play, I think, in your question there, Lexin, which is about who should bear the responsibility of doing evaluation, and maybe part of the reason the community needs to do evaluations in a
not
lot
only
of...
who should be responsible, but also what kind of remedies should we take, because there are many options that we could do this, right? We can publish results, we can publish some paper, we can make some open social media call, some voting, things like that. There are many remedies. So what kind of option that seem more promising to solve this or mitigate this problem based on your expertise in the panel?
I think, it's unconventional, but I think the chair of the panel is potentially in a good position to answer that.
Yeah, so we have a paper getting at exactly this question under review at the moment, and we're advocating for a bunch of different changes. I think like Joel was saying, the biggest problem is the research culture is not there. So thinking about how we can change the research culture to make that more incentivized and more normal. And I think we can look to the open science movement that's been taking place in all sorts of different disciplines already for clues about how we can approach that. I think things like journals and conferences mandating results being available is a really good first step, and just raising awareness of this issue is really important. And I also think that maybe part of the reason for this, the way the culture is this focus on leaderboards and benchmarks, a bit like Peter was saying before, and that if people are really just focused on getting the best results at any means, then maybe there's less of a focus on making sure the evaluations are robust and transparent.
I think to add to that, like coming into kind of the field of AI as a psychologist, one of the biggest shocks to the system was just the pace at which you're expected to publish. Like, we've got like a 2-year project and we've got like loads of papers already. I'm like, wow, it takes me 2 years to write a paper. What's happening? You don't have time to stop and stare. And actually that's what you need to do if you want to do a lot of this stuff properly. So I think it's a bit of a self-fulfilling thing in the field that it's going so quickly and you have to do stuff all the time to these deadlines. That means you actually don't have the chance to like prepare your, to release your data set properly and to do the due diligence that I think is necessary to make this an easy thing for the community to come together to do.
Yeah, and two more comments. So there is also the issue of cherry picking, which you won't solve by publishing the data because you've carefully engineered your starting conditions and after how many epochs you should stop training and so on, so you have the result that you desire. So one way of dealing with that, I don't see that happen anytime soon, but in pharmacology, people argue for pre-registering experiments. So you say exactly what you're going to do, and then you do it, and you can't deviate from it. The other thing is sort of, I think part of the issue is also what counts as a result, and what are you measuring in your experiments, right? And that's back to the issue of metrics and so on, but if you didn't measure something in your experiments, it's not there, right? And you can't sort of get it back short of running the whole thing again with extra measurements. I've been editor-in-chief of a journal myself, and of machine learning, and often people ask me, okay, why doesn't machine learning do more about, facilitating all this? It's a massive undertaking. It's not straightforward to make sure that people can submit all the stuff and that it works and that it's backward compatible. That's number one. Number two is the poor reviewers who already do all this work with reviewing a 40-page paper. Now they also need to declare that they checked that the code runs and that all the experiments are there. It's not going to happen. It's just not going to happen. So there are huge barriers, I think, towards particularly seeing the pace of development here.
Can we make an AI do it?
I think if you conceptualize things around like facilitating meta-analysis or something like that, it's like potentially more achievable, right?
Yeah.
Because then you have a model of like what another person would need if they were trying to do a secondary analysis on top of your results, and you can try to do the things that support them. And
again, this is a very narrow field of predictive machine learning, but there is, for example, there's the OpenML platform. And that is basically an experiment database. So that just says somebody with the user ID ran this algorithm with these settings and got this result.
Yeah, I think we're seeing
here's AUC and here's that, and then it's out there and people can do meta-analysis on that. Now that's in a very narrow field. How do we broaden that up to more capabilities?
I think more broadly we are seeing movements in the right direction, right? Like with model cards and platforms like OpenML. So I think we're going in the right direction, but maybe we just need to go there a little bit faster. I think that's all we have time for. So please join me in thanking our wonderful panelists.